Hi there, hope you have a fantastic day today. This lesson I want to teach you how to work out an area of a sector. Of course, there's a PDF file on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First of all, we know the area of a circle is pi r squared. So let me write this down. Area of a circle is pi r squared. But then if we want to work out the area of sector, let's say this sector here with an angle of theta degrees. So therefore, to work out this area, so we just time by theta out of 360 degrees. Because in a whole circle, there is 360 degrees in a whole circle. So therefore, we just want one fraction of it, that is theta degrees. So therefore, this area will give me pi r squared times theta over 360 degrees. And don't forget, okay, this theta here must be in degrees. But then I can make it into radian by convert 360 into radians. So to do this, we know that 180 degrees is equal to pi. So 360 degrees will give me 2 pi. So therefore, I can convert 360 degrees into radians. So area of this become pi r squared times theta over 2 pi because 360 degrees is 2 pi. So then I can just simplify this. So I cancel this pi out. So that will give me r squared theta over 2. So this can be written as I equal a half r squared theta. So therefore, area of any sector is a half r squared theta. But the theta here, okay, must be in radians, okay? There you go. So let's go through a couple examples to work this out. So we know that area of a sector is a half r squared theta. And don't forget, theta must be in radians. So it's already in radian, that is 5 pi over 6. So therefore, I just substitute this value in. R is the radius of the circle, which is 8 squared. And we times by the angle theta, which is 5 pi over 6. So that will give me, so what I do, because I want to work out the exact value, so I just put that on a calculator. So I just go a half or 0.5 if you like, and I times by 64 or 8 squares if you like, and then we times by 5 over 6. There you go. So 80 pi over 3. So 80 pi over 3, and don't forget the units. The unit is square centimeters. There you go. Second one, so we know that area of any sector is equal to a half r squared theta. And we already have the angle, but then we don't have the radius. So therefore, we need to work out the radius first. Now remember, okay, arc length is equal to r theta. So therefore, the arc length is 3 pi. Is equal to the radius, that's what we need to work out, and we need to times by the angle theta. But don't forget, angle theta must be in radian. So 60 degrees is pi over 3. If you cannot remember, you can quickly convert, okay? So 60 times by, because we want radian. So we times by pi over 180 degrees. So 6 with 0, we can cancel out. And divided by 6, that gives me 3. So pi over 3. There you go. So I can just simplify this pi out, cancel, and I times 3 on both sides. So therefore, 9 is equal to, these 3 cancel out, equal r. So therefore, the radius is equal to 9 centimeters. So now I just substitute that into the area formula. So half times the radius square, which is 9 square. and we times by the angle theta. So the angle theta is pi over 3. We already worked that out. So pi over 3. Now we just put that in a calculator, but because of exact, so we just put a half times 81 divided by 3, okay? Or I can just go 0.5 times 81 divided by 3 equal shift SD or SD, so 27 pi over 3. So 27 pi over 3. And don't forget the units, okay? Square centimeters. There you go. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? So let me go through it with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. Otherwise, let's get into this. So first of all, we need to find the exact area for this sector here. So we know that the area of a sector, let me write this down, A is a half r squared theta. And please keep that in mind, theta is in radians, okay? So at the moment, we haven't got the angle. So we need to work out the angle. And we know that the arc length of this is 5 pi. So I just write that here, okay? L is r theta. So the arc length is 5 pi. And the radius is 6. And the angle theta, we need to find out. Just write tan theta. And I just divide this by 6 and divide this by 6. So there you go. So the angle theta is 5 pi over 6. So this means that area is a half times the radius, which is 6 squared, is 36. And then we times by the angle theta, that is 5 pi over 6. Now I just simplify this, okay? So 36 divided by 6, so that gives me 6. That cancel out, that gives me 3. So that is 5 times 3 is 15. So the answer is 15 pi square centimeters. Don't forget, okay? Otherwise, you can just put in a calculator, a half times 36 times 5 over 6. And you should get 15. That means 15 pi over 6. Please pause the video and try this one yourself. Hi, I'm back. How do you go? So let me go through it with you, okay? So first of all, we know that area of a sector A equal a half r squared theta, okay? Very important. Always start with the formulas, okay? And we know that the radius, so half times the radius is 5, so 5 squared. But then we need to find the angle theta. So this angle here, we need to work it out. So, but then we know the arc length of this is 7. And we know that the arc length L is equal to r theta. So the arc length is 7. I just write this down. And the radius is 5. And which is times by angle theta. Now I just solve the equations. So I divide this by 5. I divide this by 5. So this cancel out. So therefore, the angle theta is equal to 7 over 5. So now I can just work this out now with the area. So I times by theta, which is 7 over 5. So that will give me, so I just simplify this. This cancel with this 5 here. So you leave with 7 times 5 and then divide by 2. So 7 times 5 is 35. So the answer is 35 over 2. That's equal to, or 2 go to 3 is 1, remainder 1. So 2 go to 15 is 7 times, remainder 1. So it's a half. So 0.5 square centimeters. Otherwise, you just put that in a calculator. So that's it. I hope you got it correct. Thank you so much for watching. Bye.